Hello, my name is Sherry Gates and I'm a Senior Manager with TNTP. In this session, we will shift our focus from the importance of giving kids grade-appropriate assignments to the power of rigorous math instruction. When you leave this session, you will have the tools to help you think critically about how your math instruction is building critical thinkers that have the tools they need to pursue STEM careers. To get the most out of this training, we ask that you complete Math Session 2, Grade Appropriate Assignments first. This is our second content-specific session, and we encourage all math teachers or leaders who support math teachers to join. You can expect to spend approximately 1 hour on each of these sessions. In that hour, you will watch the session videos as well as engage in some practice using various tools that we introduce throughout the sessions. All sessions will be asynchronous, and there will be opportunities for you to engage with the content. Throughout all 5 trainings, you will see 3 symbols on the screen to signal engagement opportunities throughout the session. When you see the folder symbol, you will want to open the STEM.LD resource folder. When you see the light bulb symbol, you will want to pause the video for reflection, and when you see the pencil symbol, you will pause the video for practice. At the very end of each session, there will be a short survey that will capture your attendance at the session. You will find a bit.ly and a QR code that will lead you to a Google folder with the handouts for the session. You can access them by typing the web address into your browser or by using the camera on your phone to scan the QR code. Once you do that, you will find 2 resources that we'll be using during today's training. Go ahead and open them now. In our first session together, we shared the 4 key resources that influence the student's school experience and outcomes. For this session, we are going to focus on this first one, Strong Instruction in Mathematics, where students are doing most of the thinking. We saw from the opportunity myth that spending time on worthwhile standards, aligned tasks, and ensuring that students do the work and thinking is so important. But what does that look like in a math classroom? That's going to be our focus together today. Take a moment and pause the video and read the goals. Math is also one of those polarizing content areas. In fact, many people in our society have developed math anxiety based on their experiences in math classrooms. Let's listen to these 2 middle schoolers share their experiences in math class.
I think it's kind of like prison. When you're like locked up, you have to do a certain thing every day, the same homework pretty much, and there's really no escape from it. You have to do the same exact thing. It's literally in math, the same stuff over and over again. We literally have a calendar that instructs the same thing. Like, today you're going to do 8.3.4, tomorrow you're going to do 8.3.5, so on and so forth. You feel like you're stuck inside of the textbook. You're doing nothing else except that. Everything is based around this one thing. Right now, I feel like the math textbook is kind of like the Bible of your grade. You have to kind of worship the textbook in a way to be able to get a good grade, and I don't really like that. The only time we're not learning about the textbook is when the teacher prints off a resource page based on the textbook for us to work on. And that's why it's like a prison. You can't really escape it. You feel like you're serving a sentence for like nothing sometimes.
I wonder how many of us can relate to this experience of these 2 middle school math students. Many of us maybe didn't do okay in math class. We saw it as a series of unrelated algorithms and formulas that our teachers showed us how to do, but we really had no idea why we were doing it. So there are 2 ways to engage students in learning mathematics. There's the way that the boys described in the video, show students methods and then they would repeat them. This approach is used a lot in schools and may have been the way you were taught, but the methods often lack meaning, and many students reasonably ask, why are we doing this, or when are we going to use this? Additionally, students only ever get to use what they were shown, not to select a method themselves, which is often one of the most important mathematical acts. The second approach is to engage students in rich, open, visual, and creative tasks. They use their intuition and thinking and choose methods that can be useful in a task. When they need to learn new methods, teachers teach them inside the task at hand. Students immediately see how important they are and learn them more deeply. They engage in the important acts of choosing and making connections between ideas. You can see the different approaches to solving 18 times 5 and the different type of thinking that each student did to get their answer. All of these methods are valid and can help kids become more flexible in their thinking about numbers. The algorithm works, but there's really nothing else to learn from it than the answer. The research is clear. Math is a subject that has the most potential to crush students' confidence and also the most potential to change their lives, giving them the intellectual empowerment they need. This is especially important when we think about pathways to STEM careers. Many kids shy away from STEM majors in college because of the number of math classes that are required. When we change students' beliefs about why they can do it and what they can do in math, you change their lives. That's why this work is so important. But how do we do that? How do we empower kids to be creative and confident mathematical thinkers? That's what we're going to explore today. Throughout this session, we're going to focus our learning on how to ensure that our math instruction is giving kids the opportunity to own the thinking in math class. We'll use the TDOE Math IPG protocol to help us figure that out. Please take a minute to access the resource folder that was shared with you at the beginning of the session and locate this instructional walkthrough tool. Pause this video and take a few minutes to read over the tool. Feel free to jot down any notes or questions or things you notice about the tool. If your questions are not answered by the end of this session, please feel free to reach out. For today's training, we're really going to focus on Core Action 2 and Core Action 3 sections of the tool, and we'll focus on the other two sections with your administrative teams. We're going to begin walking through the tool now. As we go through the content section of the tool, refer back to your questions. If your questions are not answered, please remember you can reach out. I'm going to start by exploring what we mean when we say high-quality instructional practices. The essential question here is, does the teacher's instructional practices support all students to learn the content of the lesson at the depth of the intended by the standards? So we want to see indicators that the teacher is making the mathematics of the lesson explicit for students so that class discussion is focused on the concepts involved and not simply on how to get the answer. From there, we want to see that students' solutions and ways of thinking are shared and discussed in class, and that those solutions or ways of thinking are used to strengthen other students' understanding of the content. To do that, teachers should deliberately check for understanding throughout the lesson by posing questions or tasks that will make students' current understanding or current misconceptions about the math visible, and then use that information to address misconceptions by students and to deepen their understanding of the math. Finally, we want to see teachers facilitate a summary of the key understandings from the lesson with references to student-generated solutions, students' discourse, discussions to reinforce the mathematics, essentially synthesizing the learning for the task or activity that just happened. So why do we look for these indicators of effective mathematics instructional practices? Historically, math instruction often focused on teaching students how to get the answer instead of employing instructional practices that make the actual mathematics explicit for students. For example, you may recognize the butterfly method on the left of the slide. This method is a method that is often taught to students to help them add fractions. First, you draw the butterfly wings and the body, you draw a plus sign for the antenna, and multiplication sign for the tail. This helps you to cross multiply and then add the numbers in the numerator and multiply the numbers in the denominator. This does indeed help students get the right answer, but it does not help the students understand the math behind fraction addition. With a strategy for how to get the answers, students might do well on an assignment, quiz, or a test on fraction addition between two fractions. But then when they are presented with more advanced concepts and problems, like the one on the right, where they have to add more than two fractions together, they will struggle mightily because they learned a procedure rather than a mathematical concept. Your Tennessee math standards, however, call for students to develop a deep, authentic command of mathematical concepts. And to do that, teachers need to employ instructional practices that make those concepts explicit and clear. So how do we make mathematics explicit for students? Students conceptualize mathematical concepts in many different ways, but equally appropriate. In nearly every moment in nearly every class, we know that many students are not processing content in the exact same way that the teacher is processing the content. For example, when the teacher references 3/4, she may be visualizing 3/4 as in 3 out of 4 slices of a small pizza. At the same time, one of her students may be seeing 75 cents. Another student may see 3 red balloons out of a total of 4. And still another may see 3/4 of an inch on a ruler. Effective instruction recognizes that students conceptualize mathematical concepts in different but equally appropriate ways. Teachers should make these different ways of conceptualizing mathematical concepts explicit for students and share them so that students strengthen their understanding of the concept at hand. The next area that we look for is evidence that students are driving their own mathematical learning and engaging in the habits described by the Standards for Mathematical Practice, which provide a guide for how students should engage with math content. The Standards for Mathematical Practice, sometimes called the SMPs, describe the habits of mind that mathematics educators in all grade levels should seek to develop in their students. There are 8 standards for math practice, but we only focus on 6 items in our tool. The reason is that we don't actually expect that students are engaged with all practices in every lesson. Instead, we look for these 6 illustrative student behaviors that collectively represent the SMPs that are most easily observable in instruction. We're looking to see that students persevere in problem solving and challenging problems, select and use the appropriate tools to solve problems, share their thinking about the math content they are learning, explain and justify their thinking, ask questions of one another to clarify or improve their own understanding, and use precise mathematical language in their explanations and discussions. These practices will help students think more critically about the problems in front of them, and the ability to engage in these practices matters just as much as mastering the math content that students are being taught. This is why these practices are critical for students to develop and are worthy of our time and attention while conducting a classroom observation. In really strong math classrooms, you are likely to see the different domains of the math observation protocol reinforcing one another. For instance, one of the best ways for teachers to support students in developing a conceptual understanding is by having them share their thinking about how they would approach a problem and have other students ask questions and explain their own thinking so that students arrive to an appropriate solution through discussion, trial, and error. So in effect, by allowing students to engage in the math practices of student ownership that you see here, students are also learning mathematics at the appropriate level, depth, and rigor that we have discussed in the high-quality mathematical content domain. So what does student ownership look like in a classroom? When I'm assessing student ownership, I start out by focusing on these 2 questions: who's doing the talking and who's doing the thinking. I'm going to show you my notes from a classroom observation. As you read through the notes, ask yourself, who's doing the talking and who's doing the thinking? Please pause the video here, read through your observation notes, and reflect. Resume the video when you're ready. So now that you've had the time to reflect, I'll share my thinking. I noticed that whenever the teacher was talking, they were asking a question. They really pushed the thinking onto the student. The teacher was the facilitator. They asked questions and modeled student thinking. This would be a strong example of student ownership. Let's take a look at another observation. As you read through the notes, ask yourself, who's doing the talking and who's doing the thinking? Please pause the video here, read through the notes, and reflect. Resume the video when you're ready. So now that you've had some time to reflect, I'll share my thinking. I noticed that the teacher did most of the talking. They told a story designed to help kids remember the steps to convert an improper fraction to a mixed number, but it doesn't actually build any understanding of why. Students only talk to share answers and how they use the cowboy method. Again, they did not have the opportunity to think about the mathematics. This would be an example of low student ownership. This was heavily teacher-directed. So let's put high-quality instructional practices and student ownership together and see what it looks like in action, or what it looks like if those components are missing. We're going to experience a short lesson. Pause your video here to open the TDOE Math IPG walkthrough tool.
So today we're going to actually start learning Target 5 using our understandings of multiplication and division to divide fractions by fractions. So today the lesson was about having students tap into what they already know about multiplying and dividing whole numbers and multiplying fractions to begin to learn how to divide with fractions. What was the big idea that we learned when we multiply fractions? What happens to the product when we multiply fractions?
I was going to say that it cuts in half most of the time.
So let's look back here up at this big idea. Multiplying by a fraction less than 1. Is 1/2 less than 1? Yes. Yeah. And when we get 8 times a half, what do we get? 4. Is the product less than one of the factors? Yes. And then we take, which is kind of similar to what you were talking about, this halving idea. It's halves one of the factors. When we multiply a third times a fourth, what do we get? 12. Is the product in both factors? Yes. So I want you to mind today as we start dividing fractions, and instead of using the language of factor and product, we're going to be looking at the language of dividend, divisor, and quotient. So today I want you to be thinking, what happens to the quotient when we divide by fractions? When you look at the standards and how they're written, the division standard is actually quite complex. It's not just a simple students learn how to use the algorithm to divide fractions, which is what we might see in some of the former state standards that are out there. But if you actually look at it and think about it, students need to understand and interpret the quotient very clearly, that it is larger than the dividend and the divisor. I want you to silently this problem. And even if you're not sure, that's okay, because that's what we're going to do today. We're going to figure out how to solve problems like this. Turn to your partner. What do you think the answer is to 3 divided by 1/2?
Because a half of 2 equals a half, and then a half. Well, no. A half of 2 is 1, and a half of 1 is 1/2.
Yeah, so if you add those two, you get 1.5, which is half of 3.
Yeah.
What were some of the answers that we had? What were some of the answers, Alondra? So one of our possible solutions is 1 and 1/2. Marlene? 6. Any others out there? Jesus?
I got 1 and 1/2.
Great. That one's already up here. Any others? All right, so we have 2 answers. These answers are quite different from one another. So now what we're going to do is we're going to try to make sense of this. Willing to share their thinking about how they got 1 and 1/2 or how they got 6?
I divided 3 divided by 1/2, and I knew that half of 3 was 1 whole and 1/2.
Okay, so you thought of 1/2 of 3 is 1 and 1/2?
Yeah.
Okay, and let's hear from another.
I don't know what the answer is, but I don't think it's 1 and 1/2 because 3 times 1/2 equals 1 and 1/2, and we're dividing.
Interesting. So let me get a different color here. So you are saying that 3 times 1/2 equals 1 and 1/2. Okay. Talk to your partner. What do you think about this statement? Is this true?
We're dividing and not multiplying. 3 times 1/2 is true because 1/2 3 times is 1 plus 1/2 equals 1 and 1/2.
So I'm actually agreeing with Annabelle that it might not be 1 and 1/2.
Okay, so you're not sure this is the correct solution, but you're also not sure what it might be. And it sounds like you've learned some sort of a procedure for dividing fractions,
Yes.
but you're not sure. You're confident with it or not? You're confident. Okay, so you think the answer is 2. Okay.
I remember that division means groups of. So they're trying to find how many halves are in 3, and that's 6.
So I'm looking 3 into groups of 1/2. Okay? Or I could say 3 into 1/2 parts. And you're saying that's 6.
Yeah, because there's 2 halves. Yeah, 2 halves. So in 3 there's 6.
Because the people saying it would be 1 and 1/2, that would be multiplication, but we're talking about division.
So you're saying that a multiplication problem and a division problem can't have the same answer?
Because, well, sometimes they can, but like in this case, because it's saying that 3 times 1/2 does equal 1 and 1/2, but I don't think that 3 divided by 1/2 equals 1 and 1/2.
The best part of the lesson today was listening to the students think about making sense of this problem, 3 divided by 1/2, and being so convinced that it was 1 1/2, which was incorrect, and trying so hard to come up with evidence for why they felt so strongly that 1 1/2 was the solution. There was the great moment when a few kids said, well, I know it's not 1 1/2, because if you multiply 1 1/2 times 1/2, you don't get 3, and multiplication is a check of division. So I loved hearing that. What I want to do right now is talk about what mathematicians do when they are trying to make sense of a problem. We're trying to make sense of 3 divided by 1/2, and we have 2 ideas. Most of us are saying 1 1/2. Some of us are saying it's not 1 1/2, but I'm not sure what it is. And then we've got some of you that are saying it's 6. So, is this our problem? All right. So I'm going to take our fraction kit pieces. We're going to try to make sense of this problem model. So if we were to do 3 into groups of 1/2, by looking at this model, I want you to look at this model and talk to your partner. 3 into groups of 1/2. How does this model help support your idea or change your idea?
What the model that you put supports my answer because 6 is also the answer, but it's because it's like how many B's go into A, and how many.
Hang on. How many B's go into A? What division statement is that? Number 2. How many B's go into A? Okay, so keep talking.
So I just put like how many halves go into 3, and I got 6. I would like to agree with my answer, which is 1 and 1/2, because if you we're dividing 3 into like its half, so it would be 1 and 1/2 if you cut that in half.
So is this problem 3 divided by 2? You're saying this is what we're doing?
Sort of.
Sort of. So you're saying that these 2 would have the same answer? Yesterday, we agreed that all 10 of these statements were true. That you could model a division statement by thinking of the dividend as A, the divisor as B, and you could ask yourself how many B's, how many divisors go into A. So if we use what Clinton said, we are B, and this would be our A. How many B's go into A? Does this make sense? 1, 2, 3, 4, 5, 6? Yes. Makes sense. So that whole moment of dissonance and disequilibrium around 3 divided by 1/2, which took 10, 15 minutes, was so great in hearing so many kids share their thinking and try to prove their idea and their answer with evidence. So I was thinking about what's long that we could divide? And then I was thinking, well, candy, it's Halloween's coming up. So I was envisioning licorice, although would you believe it, licorice is the only candy that I actually don't like. But it works for this model. Imagine we have a long rope of licorice. It's 2 feet long. And I want to divide, Ismail and Brian, I want to divide this rope of licorice into a 1/6 of a foot pieces. So my question for you is, how many pieces will I have divided into 1/6 pieces? And to do this, I'm going to give you a fraction kit for you and your partner to see if you can make sense of this problem with a model. And what I love about the Common Core in math, particularly the mathematical practices. And so for me, I feel like they have unleashed this new excitement around teaching when I'm really starting to think about not just students mastering skills, but mastering ways of thinking and thinking about how do I measure kids' ability to use models and make sense and critique the reasoning of others. So I feel like for me, it's expanded all the possibilities of what I can do with my lesson planning, and just it's challenging. So I checked in with most all of the tables except for this table, so I'm going to actually go to this table. How many pieces of licorice did you guys decide I would have? Angie? 12. And how did you figure that out?
Because like there's 6 on this side, and then we put 3 on 1/3 instead of the 6, and then it also equals 6, and 6 plus 6 equals 12.
Ah, okay. I want you to now go back to our problem, and I want you to put 3 pieces of licorice. Now your rope is 3 feet long. So go ahead and put 3 blues in the center of your table so everybody can see. And this time I want you to divide it into 1/2 pieces. 1/2 pieces. 1/2 pieces.
If you do 2 times 2, it's going to give you 6.
Yeah, it's gonna be 6.
Or 6.
Because 2 on 1/2 equals 1. Go into 3. 6 of them.
So are we convinced now that 1/2 is actually 6?
Yeah.
I'm going to mix it up one more time. We're going to do one more problem together, and then I'm going to give you a chance to practice. And the problem that I want to do now is 1/2 divided by, imagine I had 1/2 foot of licorice, the 1/2 foot of licorice, and I want you to take 1/2 and I want you to divide it by 1/4. How many pieces? I think what we'll do tomorrow is continue to finish working with the problems that we started and stopping and pausing for questions. What I'd like to do before we close is just turn your attention back here to our mathematical practices, and I want you to just call out. Did you today? Yeah. We think and reason with a situation?
Yes.
Did anybody get hungry thinking about licorice?
Yes.
Did we use evidence to support our... Ismail, did you notice how Jordan gave an example to support his idea? He was using evidence. And then also, did we critique each other?
Yes.
Yeah, we had 2 different answers for 3 divided by 1/2. Did we model?
Yes.
Did we use appropriate strategies and tools from our toolbox?
Yes.
Yep, our division statements. And were we precise with our notation and communication?
Yes.
We had to correct each other when we were using vocabulary, factor is product, dividend, divisor, quotient for division. And then last but not least, were we looking for patterns and making connections?
Yes.
Yes, we were thinking about our work with multiplying and how does that relate to division or not. So what I'd like you to do right now, we're going to close class, and for homework, I would like you to finish the page, and if you could put the fraction, that would be great.
Get ready to pause your video here to use the TDOE Math Instructional Walkthrough tool to help you reflect on this lesson. Really focus on the high-quality instructional practices and student ownership sections, Core Action 2 and 3. So, how did you rate this? I'll share my thoughts and talk you through my rationale. Also, remember that this training is not about becoming an expert rater, but rather to give you some things to think about when you're assessing your own instruction. The teacher introduces the lesson by talking about what students already know about multiplying fractions, and then references that they are going to switch from talking about factor and product, multiplication, to talking about dividend and divisor and quotient, division. Students also bring prior knowledge to bear unprompted by the teacher. For example, when a student says, I remember that division means groups of, so Finally, the teacher explicitly relates what they are discussing in this lesson to statements the class discussed in a previous lesson. This lesson is firmly grounded in building conceptual understanding of dividing fractions by fractions as the teacher engages students in a discussion of what this mathematical act really means. Students also engage in some light application of using this skill in a real-world context by dividing a piece of licorice. This lesson is not focused on procedural skills and fluency, which is appropriate given the language and focus of the standard, but particularly where they are in the sequence of learning. Determining that a lesson is correctly focused, coherent, and targeting the appropriate aspect of rigor, we then want to look to see if the teacher's instructional practice support all students to learn the content of the lesson at the depth intended by the standards. So we want to see indicators that the teacher is making the math of the lesson explicit for students so that class discussion is focused on the concepts involved and not simply on how to get the answer, and that students then have time and opportunities to work with grade level appropriate math. From there, we want to see the students' solutions and ways of thinking are shared and discussed in class, and that those solutions or ways of thinking are used to strengthen other students' understanding of the content. To do that, teachers should deliberately check for understanding through the lesson by posing questions or tasks that will make students' current understanding or misconception about the math visible, and then use that to address those misconceptions and deepen their understanding of the math. Finally, we want to see the teachers facilitate a summary of the lesson with references from student solutions or discussions to reinforce the mathematics. The teacher uses all three instructional techniques. For example, representations. She uses the fraction kit pieces to model the problem 3 divided by 1/2. She uses explanations to talk about 10 agreed upon statements about division from the previous day's class to create an explanation for the new problem of this lesson. She also represents examples. She provides a concrete example of when this kind of division might happen by sharing a piece of licorice. She also has students come up with several different answers to the problem of 3 divided by 1/2, and she solicits student solution methods for all. The teacher is careful not to dismiss any student solutions, working instead to get at the root of their thinking by bringing the whole class to a place of understanding together. The teacher checks for understanding throughout with constant questioning and circulation. One example of how she adapts after listening to student responses is the way she works with the student who persists in thinking that 3 divided by 1/2 is 6. She understands the root of his confusion and points out what he was doing is actually dividing by 2, using the model with the fraction kit pieces. We also hear the teacher reinforcing how she has checked in with all tables except one, and then she calls on that one table to share with the whole group to make sure she checks them too. There is evidence of this at various points of the lesson, including the teacher clearly summarizes and checks her own understanding of the various student solution explanations for the problem of 3 divided by 1/2. At the end of the clip, the teacher even walks through several math practice standards to highlight how students did on these things during the course of this lesson, specifically referencing student work and discussion. The instructional practices in this lesson build students' understanding of the content beyond just showing how to get the answer. I would definitely rate all of Core Action 2 as a yes and the summary as well. Finally, we look for evidence that students are driving their own mathematical learning and engaging in the habits described by the Standards for Math Practice. The Tennessee Mathematics Standards, when created, outline not just content standards, but also practice standards for how students should engage with the math content. The Standards for Mathematics Practice describe the habits of mind that mathematics educators in all grade levels should seek to develop in their students. There are 8 standards for math practice, but we really only focus on 6 items in our tool. The reason is that we don't expect to see all students engaged in every single practice in every lesson. Instead, we look for 6 illustrative student behaviors that collectively represent the practices and that are most easily observable in instruction. We are looking to see that students persevere in solving challenging problems, select and use the appropriate tools to solve problems, share their thinking about the content they're learning, explain and justify their thinking, ask questions of one another to clarify or improve their understanding, and use precise language in their explanations and discussions. These practices will help students think more critically about the problems in front of them, and the ability to engage in these practices matters just as much as the mastering of the content that students are being taught. This is why these practices are critical for students to develop and are worthy of our time and attention while conducting a classroom observation. In really strong math classrooms, you are likely to see the different domains of the math observation protocol reinforcing one another. For instance, one of the best ways for a teacher to support students in developing a conceptual understanding is by having them to share their thinking about how they would approach a problem and have other students ask questions and explain their own thinking so that students can arrive to an appropriate solution through discussion, trial, and error. So in effect, by allowing students to engage in the practice of student ownership, students are highly learning mathematics at the appropriate level and depth and rigor that we have discussed in the high-quality math content domain. In this lesson specifically, students are working with mathematical problems throughout the lesson, starting when they discuss 3 divided by half in the first 2 minutes of the clip. They persist with this particular problem, which is an instructional problem, for a long time, and later move on to solving related problems about a piece of licorice. At the end of the clip, students work with a fraction divided by a fraction, extending the concept and working toward the full level of the standard. Students share their thinking throughout the lesson, beginning when they talk to their partners about what happens when 3 is divided by half, the first problem they tackle, and continuing throughout the lesson. Students are prompted not only to share their solutions, but also the thinking behind the solutions. Nevertheless, this indicator does not receive a 4 because we don't see evidence that most students share their thinking, and it appears that the same students speak several times. The teacher consistently tells students that it's okay to struggle and that they'll get to a strong place together. The fact that students have internalized this message is evident when a student says, "I don't know what the answer is, but I think it's 1.5 because," and when multiple students are comfortable sharing their thinking, even if it's ultimately incorrect. Students don't just give the answer, but they expand on their answer with a because statement, even when talking in groups and unprompted by the teacher. Students listen and respond to each other both when working in pairs and in the whole group. Teacher specifically prompts their behavior several times by saying things like, "What do you think about this statement? Is this true?" Nevertheless, this indicator does not receive a 4 because we don't see evidence that most students engage in this behavior. Often that is because we're watching a video and we're not in person. The teacher reinforces a math word wall at the start of the lesson, where key mathematical vocabulary related to multiplication and division are posted for quick reference. Most students use precise mathematical language when discussing the target problem. This lesson solidly exhibits an integration of the math practices into the content of the lesson. However, much of that is led by the teacher and/or we do not see evidence that most students are truly integrating the standards for math practice and taking ownership to do the mathematical thinking in the lesson. We can rate correction 3 as mostly because of this. Phew, watching a video and analyzing what was happening is not easy, but you did it, and I hope that it gave you some ideas on how you can implement different parts of the IPG into your own classrooms. One thing I want us to end on, if we want to prepare kids for careers in STEM, they need to become creative and confident mathematical thinkers, not just answer getters. Many STEM careers require the ability to think through and reason around problems that don't have answers. If we only focus on answer getting in mathematics, we are not setting our students up for success. So let's take a minute to do that right now. Think about everything that we've talked about, along with any other instructional priorities that you have set as a teacher or a leader. What would your vision of instructional excellence look like in math right now? Take about 5 minutes to pause the video and write a sample statement, no more than a few sentences, outlining a clear and specific vision of what you would want excellent math instruction to look like in your math classroom or across your district. Make it clear and simple enough that all your teachers could easily articulate the same vision and set of expectations after some initial training. Feel free to work independently on this and take this back to your school site. If you are going to join us for summer PD, we will be talking more about a vision of excellent math instruction in our time together, so feel free to bring this along to really help us stamp what good math instruction looks like for those in the STEM.LD Math Deep Dive. If you are a teacher or a leader, thank you so much for participating in this learning today. I hope you enjoyed the information that you learned about, and this is the last video of our 3-part math training. The next slide will have your final attendance survey. Thank you for your participation, and please feel free to reach out with any questions. One thing I will say is I'm excited to see all of you in person in June at our STEM.LD Math Deep Dive Year 1 training in Greenville. If you have any questions about that, please feel free to give me an email. Again, my name is Sherry Gates. I work at TNTP and so excited to go along this journey with you.